any difference?
Yeah, I think now it's better. Okay,
Okay,
it
if I
has
do
to be at,
this,
yeah, it's good.
now also it's clear, right?
Yeah, now it's clear. Good.
Okay, so
Yeah.
for main piles in jacket structure, the main piles are driven right through the jacket legs, or in other words, they are called cords. So the main legs of the jacket will be called the cords. So these are your main legs. And so these main legs are called your cords.
Okay.
And this is a 1, 2, 3, 4, 5, 6, 7, 8. This is an 8-leg jacket. And so 8-cord jacket or an 8-cord jacket. So the piles will be driven right through the legs. That is the main pile. So in some conditions, some soil conditions, the main piles might not be enough to, the soil might not be enough to support the bearing capacity or the bearing load of the jacket. So in that case, in order to strengthen the jacket, to strengthen the soil, we might need to give a couple of skirt piles. So that is what skirt piles are given. Skirt piles are given in order to strengthen the soil or to consolidate the soil so that more the soil itself will have more of bearing capacity to take the load of the jacket. So that is the skirt piles which is given in the bottom.
Okay.
So that is the main pile and the skirt pile. So next one is the mud mats. So what happens with mud mats is usually, mud mats is basically a steel plate which is given in some sort of dimensions or in some design in such a way that it is designed on the basis of something called an on-bottom stability analysis. So on-bottom stability analysis is the jacket is installed on the location, it is installed, and before we do the first pile driving, the jacket has to stay in location or has to stay at location. It should not be able to float away and go, or it should not be able to float and should not be able to move. So in order for it not to move, what we do with mud mats, it's a steel plate which the moment you touch the seabed, a lot of mud is disturbed there, and this mud will be disturbed, and once the jacket is sitting on the seabed, the mud will come and rest on top of the mud mat. So what happens is more weight from the soil itself is sitting on the mud mat, and the mud mat is being supported by the jacket. So the weight of the mud itself will be holding the jacket in place along with the steel plates.
Okay.
So the mud mat is basic steel plate which is having a lot of weight, and there is mud on top of it also, so that it will still stay in position. That is the objective of a mud mat.
It's like a flat plate, fully flat.
Yeah, just a flat plate, yes.
Okay, yeah, sure.
Which is reinforced or which will be connected to the jacket braces at the bottom level. Okay, so that is the mud mat.
Okay.
Then we have skirt pre-sleeves. So these pre-sleeves are just for the skirt pile. We have sleeves through which the skirt pile will be introduced to the ground. So there are some sleeves through which, because this is all at an angle, there will be some sleeves from the top, and the pile will be inserted through these sleeves, so that it will be at the correct angle to the soil.
Okay.
That is the skirt pile sleeves. Then tubular joints. So tubular joints is a specific specialized design for jackets especially. So usually the code that we use for jacket design is something called API code. So are you familiar with API?
API?
Yes.
Yeah, no sir, I'm not sure.
Okay, API is American Petroleum Institute. So all offshore codes, basically most of these offshore structures, especially related to oil and gas, are coming under the purview of API codes. So here we are going to be following API RP, Recommended Practice 2A. That is the code which we are using for, and that is used for offshore structures.
Okay.
So RP2A, and within that is a specific design called tubular design. So this tubular design is specific because in jackets you will be mostly using tubular structures. So all the tubular structures, when there is a joint between tubular, we usually have T joints or K joints or Y joints, TKY joints. So there is a specific design for TKY joints, and what is the weld thickness, or what is the shear stress, or what is the punching shear that can be allowed. All these kind of values are mentioned in API code. So depending on that, so we have to designate all these joints as a tubular joint, and there will be specific design that will be done for all these tubular joints. So that is the tubular joint. Then we have diagonal braces. So diagonal brace is your normal brace between connecting two members. You have a brace, battered leg jacket link. Okay, so this jacket's legs or cords are supposed to be at an angle, and that angle is called a batter.
Okay.
So in offshore terms, you will call those angle a batter. And there are two types of batter. There is a single batter and there is a double batter. So single batter means when the jacket leg is at an angle to one direction, to maybe an X direction or a Y direction. That is called a single batter. And if
Batter?
the
Oh yeah,
batter,
okay.
yeah, BATTER.
Yeah.
And if the jacket leg is at an angle to both the directions, then it's called a double battered leg. So, and the angle, this inclination is provided in some sort of a ratio. That ratio is usually going to be 1:8. Sorry, 1:6 to 1:15. It will be in between that. And whether it is a double batter or a single batter, usually you'll have 1:6 to 1:15. That will be the usual ratio of the batter.
1:16 to, sorry, 1:?
1:6 to
Okay, yeah.
1:15, 1:5. Okay, so that is batter. Then we have something called launch runners. So launch runner is something which is related to the operations part, which is related to transportation and installation of a jacket. So when we actually do an installation job, we have different methodologies for installing a jacket. So after this we'll cover the operations part, TNI part, transportation installation. And when we cover that, we'll be going through the different methodologies for installation of jackets. In that, one of the installation methods is called launching.
Okay.
It is exactly what it sounds like. You will be carrying this this jacket on a barge, and from the barge, you will just launch it into the water.
Okay.
And when you do launch, the support has to be provided, very minimal support has to be provided. So what we do on the jacket is we'll just provide two beams, two huge runners, which will be just supported by the barge. And all the weight of the jacket will be supported on these two runners. That runner is called a launch runner. So we can see that detail when we cover up in T&I operations. We can see the detail of that. Next is going to be boat landing. So boat landing is basically wherever these jacket structures are there up to MSL or the mean sea level, and the top side is above that. So whenever you have a supply boat or a crew boat which comes in, they come to the boat landing and they can enter the jacket from the boat landing. There will be stairs to the top side. So that is where we have boat landing. And the boat landing will be designed for taking the impact of a crew boat or a supply boat. So it will be moved to the boat landing. And in specific cases or in certain immediate requirements in emergency situations, there might be the requirement of any other bigger ship or a ship coming or a bigger vessel coming and mooring to the jacket itself. And in that case, the boat landing has to be able to take the impact of such a vessel, dynamic impact of such a vessel also onto the jacket. So the boat landing will be designed for all these kind of loads.
Yeah.
Okay, so so moving on to the deck. There are some more terms in the jacket, which as we go ahead, we'll look into that.
Yeah.
Going into the deck, we have something called cellar deck. So cellar deck is going to be the bottommost deck, and that is called a cellar deck. On top of that, you will have a main deck, which is going to be the main functional deck of the top side. So all these top sides are going to be designed or are going to be named because of a certain requirement. So usually we have process platforms, we have wellhead platforms, we have flare platform or accommodation platform. So depending on what is the requirement, that whatever is that requirement usually happens on the main deck. So that is the main deck. Main deck is used for that. Then you have living quarters. If it's a standalone jacket and or a standalone platform in which you do not have any other complexes nearby. Complexes means any other main process platforms or any other accommodation platform nearby. You might need to have a living quarters on board. So in that case, your top side will have a living quarters and a heli deck or a heliport or helicopter transportation. Then you have derrick. Derrick is usually used in a drilling platform. If you have a drilling jacket, then you will have to use a derrick. Usually nowadays we don't have a derrick on top of platforms because there is rigs are available now. Drilling rigs are available. So usually we'll have drilling rigs coming and doing the drilling, not on top sides. Then you have crane. So deck crane is used for lifting supplies from the supply vessel or for any maintenance works on top side. They need to clean the engine head or to move a valve from one position to another position. All these things they'll be using the crane for that. So your crane is going to be designed for a huge moment. The moment means your supply crane your supply vessel might be coming with 2 to 5 tons of cargo, and your crane has to lift it from the sea level up to the top, and maybe even from heli deck. Your supply will be coming from the heli deck, so it has to carry something from the heli deck to the living quarters or to the supply store or something like that, you will use your. Then you have your other production equipments and other all modules, whichever your general loads or your miscellaneous loads will be on top of the top side. So this is an overall overview of the top side and a jacket. Yeah.
Yeah.
Okay. So in jacket, basically you have jacket legs, you have braces, joints, which we just discussed, and launch runners and trusses.
Okay.
Then you have skirt piles, upper. Okay. All other points are all together is called appurtenances. So all your boat landing is an appurtenance. Conductors, you have conductors. So conductors are the actual flow lines or your actual lines which will be transporting or which will be conducting the oil or gas, whatever is your fluid from the ground to or from the seabed to the top side.
Okay.
So conductor is the one which is going deep into the seabed, and it will usually be very small lines, or sorry, usually be big lines, which will be conducting or which will be transporting the fluid. This will be normally your gas or your crude or your oil or whatever is the fluid. Then you have bracing and guides. Then you have risers. So riser is used for transporting or conduct or moving your fluid from one platform to another or one platform to pipeline. It is used to conduct the fluid from the top side to the ground or to the seabed. And so if you have to carry or if you have to move this oil or gas, whatever you have now drilled out, if you want to move this to the onshore or you want to move this to another platform, you need to bring it out. To bring it out, you have to go down to seabed again. You have to take it to the mud line. So that pipe which takes it to the mud line is called a riser, and that riser is going to be connected to your pipeline. And then this pipeline is going to go to the next platform, and from that pipeline again there's going to be another riser which will help it to go up to the top side again. So that is the use of a riser.
So whatever we are extracting from the seabed, it goes down again through the riser.
Correct. When whatever happens in the top side happens. The top side might be used for some sort of a processing. If it is being processed, it will be processed. If it is not being processed, either way, it has to be transported somewhere. So whether it is processed or unprocessed, it has to be transported. So that transportation happens through riser. So that's the difference between a conductor. Conductor is actually transporting it from the seabed to the top side, while the riser is doing it from the top side to the mud line or from the mud line to the top side, either way. Then we have clamps. So clamps are used to keep the risers in position. Grout is your basic civil grout itself. It's a mixture of cement and sand and water. And flooding lines are used for your T&I operations. When you need to do control buoyancy of the jacket, you will be using flooding lines. Walkways are used for connection within the platform itself. There will be walkways for walking around, and even between connections between two platforms. Bridges will be connected between two platforms. Mud mats, as I explained already, mud mats are for stability, on bottom stability. And then you have J tubes, which are similar to risers. The difference being, in risers you actually have fluid flowing through it. In J tubes you have cables or umbilicals. The cables which will be controlling the valves or your electric power lines or power cables, and umbilicals will be used for your valves or for your plate connections or your PSV connections. All those kind of connections will be using J tubes. Okay, then you have in the foundations, you will be using piles, pile sleeves and grouting. Grouting is the connection between as I said, the pile is inserted through the jacket leg or through the jacket cord, and the pile is connected between each other using that annulus between them is connected or is grouted, and it is connected with the grouting. So that is why we use grout there. So for a design of a jacket, what we do is basically we have the relevant codes are RPI 2A. This is what we're going to be using. Okay, so I'm not going into design principles of it because we're not going to design the jacket as such. One more, this I wanted to show you is the offshore operations. Yeah, so now with what all offshore operations are being included in this. So basically you have, when you do your jacket design or your topside design, you have different loads that you need to consider, or there are different cases that you will be considering. So out of them, the first case is going to be your fabrication case. So in fabrication, what happens and why do you consider fabrication load case? So fabrication entails the construction of a structure carried out in the fabrication yard. It includes processes such as cutting, rolling, pressing, fitting, welding, stress relieving, etc. So this is basically your fabrication. So what is happening in your fabrication is this. This is how your jacket is being fabricated. So basically you have a structure which is being constructed on the ground, and once this row is constructed on the ground, you have the other two rows also on the sides. These two rows are also constructed on the side of the main row, and once this construction is done, you have to bring them together, and bringing them together is a process called rollover. So rollover means you will turn the row 90 degrees. It can be kept on top of the bottom row and you will weld all these together.
Okay.
So that is called fabrication. So what happens in fabrication is what the reason of why we are doing so we need to do an analysis here. So what is the fabrication or a yard analysis or a fabrication analysis means? In this jacket structure, you can see this is right now the position is horizontal. It is not vertical. So most of the jackets are built like this, unless it's a very small jacket. Most of the jackets are built like this. So and you can understand that the final jacket position is supposed to be vertical and the load is supposed to be transferred vertically. But you can see in this position, the jacket is going to be horizontal and the load you can see is being transferred only on certain points, only on the location where the joints are there. So, and the load of the jacket or the weight of the jacket has to be taken by these 3 or 4 points. So, to make sure that the jacket is safe or can be constructed in such a way it is able to carry the load even in this position, we have to do an analysis and make sure that the jacket is capable or that leg or that joint is capable of taking the load of the jacket.
Okay.
So because we're talking about we are talking about huge loads here. So even the smallest jackets might be around 1,500, 1,200 ton. So these 1,200 ton jackets should be able to take its own weight. And during the transportation, during the installation, during all this time, it is going to be in a horizontal position. And the loads are going to be distributed only in 2 or 3 points. So during all this time, all the stresses should be taken by the jacket without any damage, so that the final position also there is not going to be any issue. So that is the point of doing a fabrication analysis.
Okay.
Next is this. Usually these jackets are being constructed or fabricated on the on something called a quay side or a quay wall or on a yard, which is very close to the water. So the process of transferring this from land to a barge or to a vessel is called loadout.
Yeah.
So what happens during loadout? So there are different forms of loadout for a structure, for topside, and for a jacket. So for a jacket, you have these 3 kinds. One is going to be lifted, one is going to be skidded, and one is going to be trailer loadout. So lifted loadout means you will just use a crane and you can just lift it and move it onto the barge. In the case of a very small structure or a very small jacket, because usually even for cranes you have 2 types of cranes. You have offshore crane and an onshore crane. So usually the yard itself, most of the time you will not have an offshore crane available. You will only have an onshore crane. So the limit or the capacity of that yard is to do a lifted loadout is going to be very limited. So usually if the jacket structures are very small, is less than 500 tons, you can do some sort of lifted loadout. Or even if it's 1,000 tons, maybe you can use 2 or 3 cranes and then do the loadout or lifted loadout. But usually more than that, you will not be able to use any sort of lifting because you need an offshore crane to do the lifting. And usually you cannot use a offshore lift on the yard side. So they will be using some other form of loadout. So that's a drawback of doing a lifted loadout. And so the other format is going to be to do a skidded loadout. So a skidded loadout is when you're using a combination of skidways or skid shoes or runners, and they are propelled by jacks or winches. So what happens in this case is you usually have a main beam or a very huge runner, which is going to be going from your onshore to the barge, which is connected to the onshore and to the barge, and you will skid it on top of this beam. So you will just put your structure on top of the beam and you just keep pulling it onto the barge. So in that case, you will have to use some sort of a friction. Your friction coefficient has to be very low so that your skidding does not damage your jacket. And you need a proper winch or you need a proper pulling or a pushing mechanism in which the structure can be pushed or pulled onto the jacket. sorry, onto the barge.
Okay.
Okay, so that is your skidded loadout. Now, trailer loadout means you will be using SPMTs. SPMTs means self-propelled modular trailers.
Okay.
Those are your small trailers which have a number of wheels and axles. And these are the structures which you see in this huge refinery structure or wind farms which are being transported. So instead of using this beam, you will load your jacket or your structure onto these trailers. So these are a couple of, you will use maybe 4 or 5 trailers, and the load will be distributed in such a way that all these trailers will be able to take the loads properly, safely, and you will drive this SPMT directly onto the barge, and you will carry this along with the barge.
Okay.
So this is the loadout using the trailers.
Our top sides, will top sides be on this thing right now, on the jacket
On the
right
jacket?
now?
No, no, no. That will be
They are
separate.
separately. Yeah. Okay.
Yes, everything to do with the top side will be separate.
Okay.
They will only be meshed together, mated together offshore, not on the jacket. So now, why are we talking about loadout? Because in loadout, what happens is usually same. The first of all, the position is going to be horizontal. So you have the jacket horizontal. You have to check. On top of that, what happens is when you do lifting, you have to check for lifting loads. So lifting loads means your crane, your jacket is being supported on certain paddies or on trunnions, which are going to be your load points, or where there's going to be stress concentration going to happen. So if you have a loadout or a lifting with just 4 points, the whole weight of the jacket is being going to concentrate on those 4 points. So you have to make sure your jacket is safe there. If it's a lifting loadout, if it's a skidded loadout, you have a beam, and as we mentioned before, you have only 2 trusses, 2 launch trusses or 2 runners. So the whole load of the jacket is going to be on the 2 runners, and you have to make sure that the 2 runners are able to take the whole load of the jacket. So that is another loadout analysis. For trailer, again, the same thing. You will have the load distribution happening in 2 or 3 points only, and for these 2 or 3 points, you have to make sure that the load is being able to carry properly. Also, your loadout, your SPMT should be able to carry the loads. Should be able to. There is an axle limit or an axle capacity for the SPMTs, and they should be able to sustain that loads also. Yeah, so this is our skidded loadout. You can see how the skidded loadout is going to happen. Then we have C fastening. So C fastening is once you have this structure loaded onto your barge, you need to C fasten it for the transportation. So this is your transportation analysis or your sea fastening analysis. So what happens during transportation is that your barge will be having 6 degree of freedom. So they have 6 degree of 6 degree of motions. So you have your roll, pitch, and yaw, and you have your XYZ direction also. So for all these 6 directions, you need to make sure that your barge, your jacket is not being is not moved, first of all, and second is when you do restrict the motions, it should not be there should not be a defect, or there should not be any deflections or any damage to the jacket during your restrictions. So for that, we do a sea fastening analysis to make sure the forces are okay. So there are different types of fastening. You can use welded connections. So usually we'll be doing welded connections most of the time. When you have pipes or big pipes that you're going to transport for pipelines, etc., you will be using stanchions and lashing. So lashing will be used when you have pipes or you have small structures which you don't need to have huge welded connections or something like that. Then you will be using lashing. For pipes, usually you'll use stanchions, and welded connections are used for topsides and jackets, huge structures. Okay, so this is your sea fastening.
I've done sea fastening analysis.
Oh, you've already done. Okay.
Yeah.
Okay, so you're familiar with the gusset plates and pipes and all this.
I'm familiar with sea fastening.
So transportation is going to be including to find out your sea fastening forces, or to get your motion forces, whatever is your motion forces, you need to do this. So to get your analysis. So here we have to play around with hydrodynamics, depending on the shape of your structure, shape of your vessel. Depending on the wave conditions, depending on wind, wave, current, how your structure is going to respond to the different motions is where you will run the analysis here and find out. Towing of the structure from your fabrication yard to destination after proper sea fastening. So this is how your transportation is going to happen. This is a launch barge, and this is going to be launched into the jacket. So this is a transportation of a 8-leg jacket using a launch barge. Towing is going to be the process of moving a okay, this is nothing to do with it. This is just a how do you tow. Usually you have towing once you do install, or once you put the jacket into water, you will do towing, but that is not a very serious analysis or anything. You just need to know the tow capacity of the bollard pull of the towing vessel.
Yeah.
That's a small, very small analysis run or calculation to get the analysis, towing, bollard pull of the towing vessel. That's all.
Yeah.
Launching. Launching is the final step of transportation of a barge. It is not necessarily the final step, because there are different jackets. Depending on different jackets and different methodologies, you have either launching or lifting you can do. The objective is to put the jacket in the water. That is the objective. So you can either lift it in 4-point lifting and you can put it into water, or you can directly launch it into water in this method. If it's a topside, you will lift it. You will pick it up and keep it on top of the jacket, or it's a float over process that you will have when you do a topside. So these are the methods which you can use for installing or putting the jacket into the water. And once the jacket is in water, you have something called appending. Means you are going to, now this is the process where you will be uprighting the jacket, where the jacket is gone from horizontal to vertical. So you can do appending by two methods. One is going to be lifting and one is going to be controlled flooding. So lifting means you can lift it, you can use a crane and you can hold on to the jacket and you can just lift it, and the jacket will come upright, because you will be lifting it only from the top side, or from the top. In that case, it will automatically lift. It will become appended. Second case is by controlled flooding, in which you don't use a crane, but you use flood lines, and you will do controlled flooding of the jacket. The leg will be controlled, will be flooded by controlling the valves, and that is where the flood lines come into picture. And you will start flooding the bottom legs, and as the water fills up, that portion will go down because of the weight, and it will upright itself. And then, due to the weight, the jacket will come and sit on the seabed. So that is another way of
waterline tanks.
Yeah, means waterline tanks. As we for the step one is that the compartments are filled at the bottom of the jacket, so that the jacket can be uprighted. And then once it is upright, we have to fill at the waterline tanks so that the weight is increased and the jacket goes and sits on the seabed.
Yeah.
So this is appending crane, and the other one is not shown here, but we will be doing that in SACS to see that. We can see it in SACS how it is done. After that, there is pile driving, but this is nothing to do with our analysis. This is how we do the pile driving. The jacket leg is going, the pile is going through the leg, and the pile driver is used to drive it through. This is a topside installation. You will just lift the jacket and go install. This is directly kept on top of the jacket legs. Yeah, so that's pretty much it for an overview of the idea. So hope you got some idea on the terminology and how it works and all that.
Yeah.
I prefer that you concentrate more on the jacket portion, because topside is going to be like any other structure, but jacket portion there'll be a little bit more of a terminologies and terms coming up. The operations, all this will be different for a jacket.
So are we concentrating only on jackets? There are other
not necessarily. So that's the next point I wanted to know, because I'm not sure what you have been told or what is the expectation of what we are going to be covering here. We are basically going to go through the SACS. My objective is going to be to make you understand SACS software. We are not going to go into in-depth of analysis portions or structural design. We are not doing offshore structural design portion. We are more concentrating on on SACS software itself. So anything related to SACS software, I can cover and I can sort it out for you. Because anything more than that would be more into design portion, which is the actual design of jackets and actual design of topsides and all that. So that portion actually we are not going to be covering. So I'm not sure what they have told you about it. So I just wanted to clarify. Is there, and we will be taking, I expect to take about every 5 days of 2-hour classes. That is what